In this video, we're going to see how we can apply our understanding of linear functions to some of the more complicated worded examples. For those who don't know me, my name is Chris Iannazoni. I used to work as an engineer for a defence company, and I've since left that to start a career in tutoring. I make these videos so that VCU students can do the best they can in math methods. With that out of the way, let's get into it. The first kind of question is one where there's an incremental value and a fixed value, like this one here. This example tells us that it takes 10 minutes to cook each kilo of chicken. That's an incremental value. It changes with respect to the weight of the chicken. And we're also told that it takes a further 3 minutes to let the chicken rest. That's a fixed value. It doesn't matter what the weight of the chicken was, it's always going to take 3 minutes to rest. We can use a linear equation to model this. Let's consider t to be the time it takes to cook the chicken in terms of minutes, and let x be the weight of the chicken in kilos. The incremental value is always going to be the coefficient of the x. This is because it depends on x. It's directly proportional to that weight. Whereas the fixed value is always going to be the constant at the end of the linear. Because it has nothing to do with the x value, it's just tagged on at the end. The linear equation thus becomes t equals 10x plus 3. We can test this by just subbing in a known value. For example, if I had 1 kilo of chicken, I would expect it to take 10 minutes to cook and 3 minutes to rest for a total of 13 minutes, which sure enough is predicted by our linear equation. Now that we have our equation, it's just a matter of answering the actual question, which in this case we're told that it took 23 minutes in total for a batch of chicken to cook, and we need to figure out what the original weight must have been. Well, if we know that it took 23 minutes in total to cook, then that means that t equals 23. All we have to do from here is rearrange to get x on its own, thus giving us a solution of 2 kilos. Another common type of question is to solve a numerical series. Once again, we're going to start by creating our linear equation. This type of question requires you to find the pattern within the given scenario. If you find it hard to figure out what the pattern must be, try by guessing some numerical answers and then see if you can look at the pattern with those actual numbers instead. For example, I might guess that my starting number would be 7. That will make the next few numbers 9, 11, and 13. We would then add those numbers together. Now, that doesn't actually equal 80, but that's not really the point. The point is to try and get the pattern from that sequence. We started at some unknown point. Let's call that starting point x. Then, the next number in the sequence was just 2 digits larger. Going from 9 to 11 was a difference of 2. And that pattern persisted for the next 2 digits as well. So, we just found our pattern. And that pattern has to add up together to give 80. So all we're going to do from here is rearrange and solve for x. That's going to give us a solution x equals 17. So the final pattern is therefore going to be 17, 19, 21, and 23, which you can do a quick fact check to realize that that does indeed add up to 80. Some questions involve other areas of study, like this one here, which talks about speeds and distances. Speed and distance is a pretty common topic for linear equations, so let's have a look at how to handle it. First things first, we can often split this type of question into 2 separate journeys. In this case, we have one journey from A to B, and we have another journey, B returning back to A. In the first journey, we're told that the speed was 4 kilometers per hour. We also know that speed is calculated by distance over time. So we're going to call our distance d, and the time is going to be t1. Now, let's look at the second journey. The second journey had a speed of 6 kilometers per hour. We can also create a speed equation for that one as well. The important thing to note here is that the time taken for each journey is going to be different, but the distance travelled is going to be the same. A and B are fixed points. The distance between them is always going to be identical. So the only thing that's actually changing is the speed and the time. If you travel faster to your destination, you get there earlier. So currently we have 2 equations, but we actually have 3 unknowns. This means there must be a third equation somewhere in the information, and there is. We're told that the total journey took 45 minutes. That gives us our third equation. This means that t1 plus t2 equals 45 minutes. But this is better said as 0.75 because everything is in terms of hours and kilometers. So we have our 3 equations and our 3 unknowns. All we're going to do from here is plug into the CAS and solve. On the TI Inspire, this is located under Menu, Solve System of Equations, and then Solve System of Equations again. And on the Casio, it's the button highlighted in red. Just click it 1 extra time to increase the number of equations that you can put into the simultaneous. Okay, so the only thing we actually care about from this set of solutions is d, the distance travelled. But there's one more thing we need to worry about. we're not after just the distance that it took to get from A to B, we're after the total distance that was travelled. We made 2 of those journeys. So all we're going to do is double that result to get a final answer of 3.6 kilometres. The final type of question is what's known as a families of functions style question. This shows up in pretty much every area of study that covers functions and relations. The whole idea here is that you're given an unknown equation and you have to solve all the coefficients of that equation using the information given to you. In this case, we have to solve for an unknown linear equation, and it has to pass through 2 known points. So we have 2 unknowns to solve for, the m and the c, and we have 2 points. That's going to give us the 2 equations. So we create our 2 equations by just subbing in those 2 points into our unknown linear, and then solving through simultaneous equations. I'm just going to be using the elimination method here, since I can see a very easy way to cancel out that c variable, but feel free to use substitution instead. It'll just take a little bit longer. Once you have your answer, it's worth going back to think about what the question is actually asking. This one isn't specifically asking you to solve for the entire linear equation. It's just asking for m and c. So when you give your answer, you just give your answer as m and c, rather than giving the entire linear equation solved. If you found this video helpful, then you should consider joining my free community. I host a Q&A call every week to personally help you through any of your specific questions, and you'll also get access to more resources like this, including written and recorded lecture content, as well as practice exams and SACs with detailed solutions. It's pretty cool, you should check it out. I'll see you there.